Welcome to Embedded Weekends. In this tutorial, we'll dive into the rapid development of graphical user interfaces for an ESP32-based display module using LVGL, EEZ Studio, and Visual Studio Code with PlatformIO. We'll be working with a 4.3-inch Capacitive-touch ESP32 display module from Sunton, an affordable option featuring an 800 by 480 pixel IPS RGB display and a USB Type-C programming interface. This module also includes a micro SD card slot for additional storage, along with 1mm pitched and 1.25mm pitched ports that expose power, serial port, and several GPIO pins. With minimal code adjustments, the demonstrations in this tutorial can also be adapted for use with other ESP32-based display modules, such as the CrowPanel displays from Elecrow and the Gen 4 ESP32 series from 4D Systems. By the end of this tutorial, you'll have built an application featuring multiple screens and a variety of interactive widgets, including buttons, bars, arcs, labels, a text area, and a keyboard. These widgets will interact with the serial port and control external components like LEDs, a buzzer, and a potentiometer. To design and lay out the screens and widgets quickly, we'll use EEZ Studio, an open-source design tool that generates LVGL-compatible code. LVGL, coupled with the Lovian GFX library, will handle rendering of the GUI on the ESP32 display module. We'll use Visual Studio Code with PlatformIO to develop the code that allows these widgets to interact with external components. This tutorial also highlights a streamlined approach to GUI development by separating the UI design from the business logic. EEZ Studio manages the graphical interface, while Visual Studio Code handles the back-end logic. We avoid manually modifying the LVGL code generated by EEZ Studio, as these changes would be overwritten with each update to the design. Additionally, the process is simplified by eliminating the need for tedious and error-prone manual copying and pasting of multiple files during UI development. Visual Studio Code's autocomplete feature further enhances efficiency by automatically detecting and listing widget names from the generated UI. This method enables us to efficiently develop, test, maintain, and scale GUI applications, making the process of creating a polished, interactive display both manageable and effective. Let's get started. To follow along with this tutorial, you will need the following hardware components and software tools. Hardware: ESP32-8048S043 display module. This is the primary display we'll be using. Ensure you have a Type-C USB cable for connectivity. If you're using a different ESP32-based display, whether it's a different size or brand, don't worry, many of the principles will still apply. Be sure to subscribe to this channel and hit the notification bell for future tutorials tailored to other displays. Software: Visual Studio Code with the PlatformIO IDE extension. The version used in this tutorial is PlatformIO IDE version 3.3.3. EEZ Studio. We'll be using version 0.14.2 for this demonstration. You can find links to download the necessary software tools in the comments section below. External components: a couple of LEDs with series resistors, a buzzer, a potentiometer, a breadboard and a set of connecting wires. Connectors for the display module: a 4-pin female 1.25mm pitched connector, a 4-pin female 1mm pitched connector. Setting up a PlatformIO project in Visual Studio Code. Start by going to the provided repository and either clone or download the specified branch. The link to the repository is posted in the description section below. Rename the project folder and move it to the PlatformIO projects folder. Open the project in Visual Studio Code. Wait for PlatformIO to finish setting up the project. This may take a while. While waiting for the project to be set up, explore the code. Locate the main.cpp file. This file contains the bare minimum code required to run an LVGL project on the display. Use a USB cable to connect your display module to the PC. Ensure that the connection is secure and that the display module is powered on. Build the project and upload the program to your display module. After the upload is complete, you should see a label appear in the center of the screen. This confirms that the basic LVGL setup is functioning. Open the Serial Monitor utility in Visual Studio Code. Press different areas of the display and observe the serial monitor. The touch coordinates should be printed in real time, confirming that the touch panel is working correctly. In the bottom right corner of the display, you'll notice the LVGL System Monitor log. This log is useful for tracking performance metrics. Later in the video, we'll cover how to disable the LVGL System Monitor. We'll be using Git to track changes in our project. Start by initializing a Git repository for the project through the Source Control sidebar menu in Visual Studio Code. Once the repository is initialized, you'll see the changes listed in the Source Control panel. To stage all changes, click on the plus button next to Changes. This will prepare the modified files to be committed to your repository. After staging the changes, commit them by typing a meaningful commit message in the message box and clicking on the checkmark icon. Creating an EEZ Studio project. Launch EEZ Studio to begin creating your project. Select the template named LVGL. Note that the LVGL with EEZ Flow template is for projects utilizing EEZ Flow, a powerful low-code feature that simplifies the creation of more complex LVGL projects through a visual, flowchart-like approach. Future tutorials on using LVGL with EEZ Flow will be available on this channel, so be sure to subscribe and click the notification bell to stay updated. Set the name of the project. Set the LVGL version of the project to 9.0. For the location, navigate to the source folder of the Visual Studio Code project. By default, a label is added to the main screen of the project. To configure the build settings, create the folder UI under the source folder. Then set it as the destination folder. Set the LVGL include property to LVGL.h. To save and build the project, click the Save button to preserve your modifications. Click the Check button to verify your changes. Click the Build button to generate the LVGL files. In Visual Studio Code, go to the Source Control section and view the files under Changes. These are the files generated by EEZ Studio. Click the plus button to stage all changes. Add the following lines to main.cpp. At the top of the file, add hash include UI/UI.h. Under Setup, disable the last hash if block and add UI_init. Under Loop, add UI_tick. To build and upload the project, click the PlatformIO Build button. Click the PlatformIO Upload button. Check your display. The text should now be updated accordingly. Modifying label properties in EEZ Studio. Navigate to the main screen and select the label object. Adjust the label's color and font properties. Drag the label on the editor screen to center it. EEZ Studio provides visual guides to help with precise centering. Click Save, then check to verify the changes, and finally build to generate the necessary files. In Visual Studio Code, go to the Source Control section and review the files listed under Changes. This step can be valuable for learning LVGL and for tracking, reviewing, or undoing changes if needed. In Screens.c, you might see a squiggly line under the function LVGL Object Set Style Text Font. This indicates that a specific LVGL font needs to be enabled to prevent compilation errors. To fix this, open lvconfig.h and set LVGL font Montserrat 30:1. The squiggly line should disappear, confirming the issue is resolved. Go ahead and stage these changes in the Source Control section. Making this a habit will help you effectively track any subsequent modifications. Click the PlatformIO Build button, then the Upload button. The label on your display should now reflect the updated properties, demonstrating how easily you can adjust the position, font color, and font size of a label object. In this part of the tutorial, we'll demonstrate how to create an LVGL button object using EEZ Studio and how to process its events in the main loop of your code. In LVGL, events are triggered by various user interactions, such as when an object is clicked, scrolled, redrawn, or has its value changed. These events can be processed by attaching an event handler function to the object. For more detailed information, refer to the LVGL documentation. EEZ Studio requires user actions to link screen objects to their respective event handlers. This tutorial will show you how to continuously add objects to your project and conveniently process their events using user actions. Creating a button in EEZ Studio. Add a button to the project and name it Main00 button next. Add a label to the button and set its text to Next. Adjust the font. Resize the button to fit your design. Notice that when you move the button, the label does not move with it. To ensure the label moves with the button, set the label object as the button's label by dragging the label object to under the button in the widget structure pane. Move the button again, and this time, the label should move along with it. Go to the User Actions tab and create a new user action. Return to the button object and, under the Events section of the button's properties, create a new event handler. Set the event property of the new event handler to Released, and the action property to the user action you just created. Click Save, then check to verify the changes, and finally build to generate the necessary files. Implementing the event handler in Visual Studio Code. In Visual Studio Code, you'll notice that a new function has been declared in actions.h. You'll need to define this function in a separate C file. Create a new source file named actions.c and define the function as follows. This code will assign the LVGL event to a global variable, which can then be accessed in the main loop to process the event. This user action can handle events from all objects, so you won't need to repeat this process for each new object added in the future. Open main.cpp and add the necessary changes to process the button event in the main loop. Additionally, disable this block under my touchpad read to prevent interference with later tests. Build and upload the program to the display module. Open the Serial Monitor utility and click the button on the display. You should see logs indicating that the event source, in this case, the next button, is being correctly processed, with the button's address being printed when clicked. In this part of the tutorial, we'll demonstrate how to create an additional screen and how to use buttons and their events to navigate between screens. Creating a new screen in EEZ Studio. Navigate to the Pages tab in EEZ Studio to create a new screen. Name the new screen object Screen 00. Return to the main screen and copy the existing main 00 button next button. Switch to Screen 00 and paste the copied button twice. Rename the pasted button objects. It appears that we made a spelling mistake with the name of the button on the main screen earlier. Let's correct this by updating the button name to ensure consistency. Adjust the vertical positions of the buttons to ensure they are evenly spaced. Add labels to the screens to facilitate easy identification during testing. Note that when you copied the main 00 button next button, its event handler was also copied. As a result, the events for the duplicate buttons will be received and can be processed in the main loop. Click Save, then check to verify the changes, and finally build to generate the necessary files. Switch back to Visual Studio Code and update the main loop to handle navigation between the two screens using the buttons and their events. Make sure to reference the appropriate LVGL objects. Note that the autocomplete feature of the IDE significantly simplifies the process by making it easy to identify and utilize LVGL objects in your code, ensuring accuracy and efficiency. Build and upload the program to the display module. The navigation between screens should now work as expected. This approach allows you to continuously enhance the user interface by adding new objects and screens in EEZ Studio. Meanwhile, you can separately update the business logic in main.cpp by processing the global event variable. In this part of the tutorial, we'll demonstrate how to control an external LED using an LVGL button and its associated events. The 4.3-inch Capacitive-touch Sunton display includes extended I/O ports that expose several GPIO pins of the ESP32S3. For this demonstration, we'll use pin IO11 on port P2 as an output pin to toggle an external LED. You can use other pins, but be sure to consult the schematic diagrams, as some GPIO pins are allocated for other functions. For instance, IO18, IO19, and IO20 are used for interfacing with the capacitive touch controller. IO11, IO12, and IO13 are generally used for the micro SD card slot. However, since this tutorial doesn't use the micro SD card slot, these pins are available for other purposes. Links to the schematic diagrams are provided in the description section. Note, however, that updated documentation for Sunton display modules, especially for revision 1.2 of the ESP328048S043 PCB, may not be readily available. Other ESP32-based display modules offer excellent documentation and support. For example, the CrowPanel displays from Elecrow have complete and up-to-date documentation and schematic diagrams. The Gen 4 ESP32 series from 4D Systems is also well documented and well supported. Links to these LVGL certified products are also available in the description section. In EEZ Studio, navigate to screen 00 and create a new button object by duplicating one of the existing buttons. Adjust the properties of the new button as needed. Click Save, check, then Build to generate the updated files. Return to Visual Studio Code and update the main loop to handle GPIO control using the LVGL button and its events. Build and upload the program to the display module. Connect the anode end of an external LED, which should be wired in series with a current limiting resistor, to pin IO11 on port P2. Keep in mind that port P2 is a 1.25mm pitched male connector. Ensure that the external LED and resistor circuit share a common ground with the display module. Use the LVGL button on the display to toggle the external LED connected to pin IO11. For this demonstration, I'm using a separate development board with onboard LEDs, buttons, potentiometers, and other components. In this part of the tutorial, we'll add a buzzer that beeps every time a button is pressed, providing auditory feedback to enhance the user experience when interacting with the display module. For this demo, we'll use pin IO17 on port P4 as the output pin to control the external buzzer. As previously mentioned, you may choose other pins, but be sure to consult the schematic diagrams to avoid conflicts, as some GPIO pins may serve other purposes. In Visual Studio Code, navigate to the main loop and add the necessary code to trigger the buzzer whenever a button is clicked. Build and upload the program to the display module. Connect the external buzzer to pin IO17 on port P4. Keep in mind that port P4 is a 1mm pitched male connector. Press any of the LVGL buttons to hear the buzzer connected to pin IO17 beep. For this demo, I'm using a separate development board with an onboard buzzer and other components. In this part of the tutorial, we'll demonstrate how to use pulse width modulation, PWM, to vary the brightness of an external LED. The PWM signal will be controlled using the LVGL Arc object. For this demo, we'll use pin IO12 on port P2 as the output pin for the PWM signal. As always, you may use other pins, but ensure they aren't allocated for other functions by consulting the schematic diagrams. In EEZ Studio, create a new screen object and name it Screen01. Copy the label and navigation button objects from Screen00 and paste them into Screen01. Update their properties as needed. Add an arc object to Screen01, adjusting its size and position accordingly. Set the name of the arc object and assign the appropriate event handler. Click Save, check, then Build to generate the necessary files. In Visual Studio Code, navigate to the main loop and add the code required to handle screen navigation and PWM control on pin IO12. Build and upload the program to the display module. Connect an external LED and a series resistor to pin IO12 on port P2. Navigate to screen 01 on the display, then move the knob of the arc object to adjust the brightness of the external LED connected to pin IO12. In this part of the tutorial, we'll show you how to dynamically update the value of a label object during runtime. In EEZ Studio, navigate to screen 01 and create a new label object. Set the label's properties. For this label object, you need to set a name so you can reference it later in the main loop. Click Save, Check, and then Build to generate the necessary files. In Visual Studio Code, go to the main loop and add the necessary code to display the PWM modulation level on the label. Build and upload the program to the display module. Navigate to screen 01 on the display. As you move the knob of the arc object, the label's value should update in real time to reflect the current PWM level. In this part of the tutorial, we'll demonstrate how to use LVGL bar objects to visualize ADC input values on your display module. For this demo, we'll use pin IO13 on port P2 as the ADC input pin. You may also use other GPIO pins, but consult the schematic diagrams to ensure they are not used for other purposes. In EEZ Studio, create a new screen object and name it Screen02. Copy the label and navigation button objects from an existing screen, paste them onto Screen02, and update their properties as needed. Add a horizontal bar object to Screen02 and adjust its size and position accordingly. Set the properties of the bar object. Add a label object next to the horizontal bar and set its properties. Add a vertical bar object and adjust its size and position. Set the properties of the vertical bar. Add another label object next to the vertical bar and configure its properties. The horizontal bar and its label will be used to display raw ADC input values. The vertical bar and its label, on the other hand, will be used to display scaled ADC input values. Click Save, check, then Build to generate the necessary files. In Visual Studio Code, modify the main loop to handle navigation to and from Screen02. Add code to read the ADC input from pin IO13 and display the raw and scaled values on the respective bar and label objects. Build and upload the updated program to the display module. Connect the middle or output pin of an external potentiometer to pin IO13 on port P2. Connect one of the outer pins of the potentiometer to the 3.3-volt pin, and the other outer pin to the ground pin of the display module. Navigate to screen 02 on the display and rotate the knob of the external potentiometer. The raw and scaled ADC values should be reflected on the bar and label objects. For this demo, I'm using a separate development board that has onboard potentiometers and other components. In this part of the tutorial, we'll explore how to use LVGL's keyboard and text area objects to enable text input and display on the screen. We'll also delve into some of the keyboard and text area features, such as automatic cursor handling and various input modes like alphanumeric, numeric, and password. Finally, we'll demonstrate how to send the inputted text to the serial monitor, showcasing the potential of using the display module as an input device with limitless possibilities. In EEZ Studio, create a new screen object and name it Screen 03. Add a text area object to the screen, then resize and position it as needed. Configure the font and name for the text area. Assign an event handler to the text area. This handler will trigger an event in the main loop whenever the text area's value changes. Add a keyboard object to the screen, resize, and position it below the text area. Set the name of the keyboard and link it to the text area. Add event handlers for the keyboard. These handlers will enable the keyboard to send events to the main loop when the ready or cancel button is clicked. Click Save, check, then Build to generate the necessary files. In Visual Studio Code, modify the main loop to handle navigation to and from screen 03. Add code to send the string from the text area to the serial port. Build and upload the updated program to the display module. Open the Serial Monitor utility on your machine. Navigate to screen 03 and start typing on the keyboard. The characters should appear in the text area and simultaneously be sent to the serial monitor. Tap on the text area to display the cursor. You can move the cursor by tapping different parts of the string or using the arrow keys on the keyboard. Click the Ready or Cancel button to return to screen 02. This example demonstrates how to integrate an alphanumeric keyboard into your LVGL project, providing a flexible and powerful text input interface. In this section, we'll modify the keyboard object to function as a numeric keypad in password mode. This is particularly useful for applications requiring PIN or passcode entry. Select the existing keyboard object. Set the mode to number. Update the font. Select the text area object. Enable password mode to mask the input. Click Save, check, then Build to generate the necessary files. Add the following line of code to the main loop to trigger a buzzer beep each time the text area value is updated. Build and upload the updated program to the display module. Open the Serial Monitor utility to observe the output. Navigate to screen 03. The keyboard object should now function as a numeric keypad, with the text area displaying masked characters. Each time you input a value, the buzzer should beep, confirming the update. This demonstration highlights how easily you can adapt the LVGL keyboard object for different application needs, such as secure numeric inputs. In this part of the tutorial, we will disable the LVGL system monitor. In Visual Studio Code, open the file lvconfig.h and update this line. This will disable the LVGL system monitor. Build and upload the updated program to the display module. The LVGL system monitor logs should no longer appear on the display. Thank you for following along with this tutorial. I hope you found it helpful in getting started with your 4.3-inch Capacitive-touch ESP32 Sunton display module. If you enjoyed this video and want to stay updated with more tutorials and tech content, please subscribe to the channel and hit the notification bell so you never miss an update. Your support means a lot, and it helps the channel grow. See you in the next video.